So, what can I help you with today?
Can I send you a picture of this? Because this, I don't think I can visualize this.
Yeah. Do you have my email address?
I forgot it, sorry.
Let me write it on my screen. You can see this, right?
Yeah.
gmail.com. Let me guess. We're doing volumes of three-dimensional objects.
Yeah. And, some, like, missing it values things.
Okay. That would be particularly hard to verbalize if you had drawings of three-dimensional objects, like prisms and stuff like that.
Yeah. Oh, I gotta take another picture.
Have you ever sent me a photo?
Yeah.
Okay. Yeah, once you put in the email address the first time, then the next time you generally just have to put in the first two letters of my name. And it'll show you the list of emails you've sent to.
Oh.
So is your final next week, or is it like tomorrow?
It's, next week.
Okay. Holler when you've sent it. Sometimes it can take a minute or so for it to get to me.
Okay, yeah, I just sent one of them.
Okay. So you're just reviewing semester material now, right? You're not learning any new material?
Yeah, we're just reviewing.
Okay. Still waiting.
Okay, and I just sent the second one.
Okay. It's good to send them separately, actually. They get here quicker if there's only one picture attached. Ah, see, that's it. My phone is receiving that. And it actually gets to my phone before it gets to me, before it gets to my computer.
Oh, really?
Uh-huh. I think that's what that would have to mean.
Yeah.
The fact that my phone whistled at me. And I didn't get the second one yet, but that's okay. Let's open up the first one here and see what we got. Okay. Do you know what M is?
No.
9. In other words, because this line bisects this angle, it's also going to bisect that.
Oh, okay. So it's 9.
And let me think for a moment here. I guess that's just a theorem of geometry. Because there's no similar triangles. We have same angles, same side, but that's it. So we're not looking at similar triangles. But regardless of how I were to draw this line right here, notice that even if I drew it straight across, it would be bisected. Even if I drew it at an angle like this, it would be bisected.
Yeah.
So as long as this angle here is being bisected, that line gets bisected.
Okay.
All right, let's look at 2. Okay, now here we have similar triangles. Hold on. Get this thing. In other words, this top triangle here is similar to this bottom triangle. Only because they tell us that this line is parallel to that line. Okay? Since that's parallel to that, that angle's the same as that angle's the same as that angle, and they share that angle in common. So it's an angle-angle similarity. So because the two triangles are similar, what relationships, what ratios can I state?
Can you do 18 over 4?
Yeah, you can actually put these together in a lot of different ways, but that's one way.
And then n over 6?
So n equals 108 divided by 4, which is 27.
Okay.
Okay. And now, how do you get O?
I'm not really sure.
Well, we have two triangles now. There's the top one. Okay. Here's the bottom one. Bigger, but similar. And this distance is 18 plus 4. This distance is 27 plus 6, so it's 33. So what ratio can I come up with if these are similar triangles?
18 over 22 equals 27 over 33.
Well, we're trying to solve for that.
Oh. Could you do 22 over 33 equals 30 over...
Well, hold on, let's back up. When you have similar triangles, there's lots of relationships you can make. You can say 18 is to 27 as 22 is to 33. But you can also say 18 is to 22 as 27 is to 33. See the difference?
Yeah.
Okay, since we're solving for O, let's make 18 is to 22 as O is to 30. In other words, proportional side, not the same sides, the similar sides are proportional to one another because the two triangles are similar.
Okay.
So solve that, and you get 30 times 18 over 22. That equals O. And let's see, what can I do here? I guess I can cut the top in half. Just use a calculator, I suppose.
Yeah.
Come up with that number. You're good with coming up with the number?
Yep.
You have to turn this in, so you need specific answers, correct?
Yeah.
Okay. But you got a calculator in front of you?
Yeah, I do.
Okay. It's worth, once you come up with O, it's worth ballpark checking it. One thing we know for sure is that O has to be smaller than 30, right?
Okay, and I got O is I got 24.5.
Okay, that's good. Are you supposed to round off to the nearest tenth, 100th?
10.
10th, okay. Let's have a look at 3 here. Well, what should we do with 3?
I don't know.
Let's see, what do we got? We got 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. They're all different angles. So this is a polygon, but it's not a regular polygon.
Okay.
Okay? We can do a few things with this thing. Let's see if I can almost recreate it, because I'm going to have to in order to do the stuff that I'm thinking we're going to do. I can only think of one way to solve this thing. All right, we got A, B, C, D, E, F, G, H, I. All right, that's 15. This is 20. This is 35. Now, the fact that they only give us this information.
And they give you the other, the other polygon.
Oh. Are these two similar? No.
Yeah.
No. Yeah, they are. Where does it say they're similar?
I think it says it right below them.
Ah. A, B, C, D, I get it, is similar to this. Okay. Now I get how we're going to solve it. I was going to get real creative. Okay, so the only thing we have to do is orient it. The second one relative to the first one.
Yeah.
Don't have any similar angles, do we?
Nope.
But if you look at its shape, it's oriented properly right now.
Yeah.
Okay, so let's go through. What's angle A going to be?
161,
Okay.
and then
And let's see, angle D is going to be 133. Angle F is 147. And that's it for the angles, right? We had 2 angles from that, 3 angles from that, so we have 5 angles. Now, and the relationship between the sides is what? Corresponding sides.
15 to 9.
Okay, let's do 15 to 9, which means that this side here, BC, in other words, 15 is to 9 as BC is to 21.
Okay.
See that?
Yeah, so you just top multiply.
Solve for BC. Tell me what you get.
Okay.
So I can plug it in.
Okay. I got 35.
Okay. And let's see, what else can we solve for? We can solve for CD. 15 is to 9 as CD is to what?
21.
That's CD right there. That's the corresponding side. 7.5?
7.5. Yeah.
Okay, go ahead and solve for CD.
Uh, 12.5.
Okay. And let's see. What else can we solve for here? Let's see, we were given 3 sides over here, 3 sides over there, so, and 2 of them were the same, so we should end up with 6 total sides. 1, 2, 3, 4, 5. Which one am I missing? I got 20. I got that one. So hold on a second. Let's see. I got 1, 2, 3, 4, 5. That's all we should have immediately. Now, let's see what they're asking for. I'm not sure they're asking us to solve the whole thing. BC they want. We got that. CD they want. We got that. WV.
Yeah.
What's WV gonna be?
It's 15 over 9, and 20 over WV.
Good. Come up with WV. 12, okay. And WX, we can come up with that also. Let's find the relationship that gives us that.
Okay, so it's 15 over 9 equals 35 over WX.
Okay.
21.
Okay. And then they want angle A, which we figured was 161.
Yep.
Angle D, which we have as 133, and angle Y is what?
Angle Y is 120.
Okay. So thank goodness they didn't want us to solve this whole polygon, because I didn't have a clue as to how we were going to come up with the other angles, to be honest. I was going to start dividing it into triangles and trapezoids and all kinds of stuff. But I don't know that that would have worked. But they didn't ask about it. Only the stuff they asked about was the stuff we were able to figure out. So,
yeah.
Okay. Okay, a bunch of parallel lines. Well, let's see. Again, we have a bunch of similar triangles, right? This triangle is similar to the big one. This middle triangle is similar to both. This third triangle is similar to all 3, and this triangle is similar to itself and all the other ones. So let's see, what can we figure out? How about we figure out Z? How can we figure out Z? For starters.
Okay.
What's the relation?
Okay, how would we do that again?
Well, we've got this measurement is to that measurement. In other words, the ratio within one of the triangles. 12 is to 21. As this entire side is to Z. Well, that entire side adds up to be 68.
Oh, okay, and then you just solve it?
Uh-huh. So what do you get there for Z?
119.
Okay. That makes sense. Now, thinking, what can we solve for next?
We can get...
we have a relationship between this side and this side. Now, granted, that's not a triangle, that's a quadrilateral, but that relation, all of these quadrilaterals are similar also. In other words, this quadrilateral here is similar to this one, is similar to that one. And they only give us one relationship, which is 28 is to 35. So we're going to use that a lot here. So 28 is to 35, and let's solve for v. Yeah, it's a little harder to say that. Let's solve for w first. In other words, since we're comparing this quadrilateral to this quadrilateral, let's solve for w.
Okay.
So 28 is to 35 as what?
As 8 is to w.
Okay. Now, notice one thing here. When you solve this, you have to do two steps, right? You have to cross multiply, and then you have to divide by 28. But if I were to write it this way, 35 is to 28 as w is to 8, which is just as correct. Notice I only need one step. Because the w is in the numerator, I can solve it. I don't have to cross multiply. The only thing I need to do is multiply both sides by 8. Okay.
Okay.
So what do you get for w?
10.
Okay. So we've solved for v, for w. Let's use that same relationship to solve for x. This quadrilateral is similar to this quadrilateral. Only this time let's use this relationship.
Okay.
Bottom one. So what would the right half of this be?
X over 20.
Yeah, and then that's easier to solve.
Okay, and then 35 over 28.
Right.
And you get 25.
Okay. Now let's solve for y. We've solved for z already. What relationship can we solve for, use for y?
You can use, what is this? 68 over 119.
That was z?
Yeah. And then,
Equals what?
Equals 8 over y?
Not 8.
Oh, 20 over y.
In other words, if you're going to use similar triangles, then you have to use that whole side. Or you could just say, yeah, 20 over y. And again, we could have written it backwards if we were thinking ahead, but that's sometimes hard to do and not that necessary to do. In other words, it's fine if it takes 2 steps, you still get the answer.
Yeah, and it's 35.
Okay. And that's all of those. Which one do we want to do next?
We could do number 1 on the LAV.
This one, Eddie, who's 6 feet tall?
Yeah.
Okay. These word problems like this are always just triangle problems. Okay? In other words, if you're standing 6 feet tall, you're at a right angle to the ground. Who is 6 feet tall, standing at the bottom of a cliff which is casting a 72-foot shadow. There's the shadow. There's Eddie standing tall, and there's a huge cliff over here. And the sun is way off here to the upper right, but it's causing a shadow to be cast. like that.
Mm-hmm.
Okay? If Eddie's shadow is 10 feet long, how tall is the cliff? I get it. I got the picture wrong here. Hold on, let me redraw it here. This cliff is casting a 72-foot shadow. And Eddie is casting, he's standing 6 foot tall, and they want to know how far that distance is there.
Oh, okay.
If Eddie's shadow, excuse me, they're saying his shadow is 10 feet. So how tall is the cliff? I guess, I'm a little confused on their wording here.
Yeah.
Standing at the bottom of a cliff, yeah, their wording is a little fuzzy, but assuming we've drawn the right picture, how would we figure out how tall that was?
Would you do 6 over y equals 10 over 72?
Yeah, you could do that, but let's do y over 6 instead.
Okay.
Y over 6 equals, well, I'm not sure it's 72 over 10. It depends on whether this 72 goes from there to there. If it does, then it's 72 over 10. If the 72 just goes to there, then it's 82 over 10.
Yeah.
I don't know what it is, to be honest. I can't even quite picture. Eddie's shadow is 10 feet long. Wouldn't the cliff shadow overshadow Eddie's shadow and you wouldn't be able to see it? In other words, the way I've drawn it here, you wouldn't see Eddie's shadow. You wouldn't know it was 10 foot long because the shadow from the cliff and Eddie's shadow are going to be the same way.
I don't like the way they do word problems.
Yeah, this one particularly sucks. Mainly because it's hard to imagine what they're talking about. I suppose Eddie could be on the other side of the cliff, but no. If Eddie is anywhere from here to here, you're not going to see his shadow. The only place Eddie could be was right here. That's what the picture's got to be. Okay, let me draw this picture again. We'll get it right here. Here's the shadow from the cliff, 72 feet. Eddie is standing right there. He's 6 foot tall. He has a 10-foot shadow. That picture makes sense now. Okay?
Yeah.
Because the cliff shadow would run out. Eddie's standing at the tip of the shadow, standing up. He's got his own shadow. Okay. So now you can say y is to 72 as 6 is to 10.
Yeah, and you get 49.2.
Okay. That's how tall the cliff is. Okay. Was that one? Which I can't quite see the next one. The one that says dig this.
Oh, okay. Yeah, we can move on from that one because I think I understand the concept of that.
Okay. Let's just talk about, I can help with the concept there because I think I know what they're talking about. If the diameter of a small drink is 2 inches, while the diameter of a big drink is 5 inches, if the cups are similar and the volume of the large drink is something, what is the volume of the other drink? Well,
yeah, the volume of the large drink is 75 pi.
Hold on, let me draw these better. They're 2 cylinders. They're 2 cylinders that are similar. Okay? That's 2. That's 5. What's the volume of the large drink? Or
The volume of that drink is 75 pi.
75 pi, was that small or large?
Large.
So the volume is 75 pi. Okay, what's the formula for the volume of the large drink? What's the general formula for the volume of a cylinder?
The volume. What's the formula for the what?
Volume of a cylinder. That's what we have, is two drinks that are in the shape of cylinders.
The volume of cylinder.
Mm-hmm.
What is the volume formula?
It's the area of the base, capital B, times the height.
Okay. Oh, okay.
Okay. Hold on. If the cups are similar and the volume of the large drink is 75, okay, here let's work it out. The volume of the large drink is, the area of the base is what?
70.
Area of the base. In other words, we know that volume is the area of the base times its height. And we don't know its height, but we do know the area of the base.
Oh, 5.
No, that's the diameter of the base. It's pi r squared. Area of a circle.
Okay.
So what's pi r squared?
It's 61.6.
Leave it in pi, and I'll tell you why. In other words, what it is that squared is 6.25, right?
Yeah, 6.25.
Okay. So we know the volume is 6.25 pi times h, and they tell us the volume is 75 pi. So that allows us to solve for h. Notice the pi's cancel, and h is equal to 75 divided by 6.25. So what do you get for h?
12.
Okay. So the height is 12. Since we have similar cylinders, what's the height of the smaller cup?
The height of the smaller cone is...
What's the ratio? Give me the ratio. Let's start with height of the smaller cup. In other words, let's put it in the numerator because that's what we're going to solve for.
Okay, so h over 12 equals 2 over 5.
Okay. So h is 24 divided by 5, which is 4.8.
Yep.
And they want the volume of the small cup, right?
Yeah.
Okay, well, we've got its radius, and we know its height, so using that volume formula, volume is pi, what's r?
1.
Squared is still 1, times h, which is 4.8. So its volume is 4.8 pi.
Oh, okay.
Now, notice something. If you were doing a check, you might think, well, that's weird. That doesn't sound right. This diameter is 2.5 times this, but this volume is 15 times this.
Yeah.
It's true.
Okay.
When you have a relationship between two similar solid figures, and you're comparing their one-dimensional relationship, the volume relationship is going to be the cube of that. In other words, the volume relationship is not going to be 5 to 2, it's going to be 5 to 2 cubed, which is 125 to 8 which is like 15 times. And that's about what we're looking at, is 15 times.
Okay, thank you.
Okay. Let's go to the next one here. Okay.
Oh, and then under the volume for the bigger one, it says surface area is 1936 pi.
And that's the one whose volume is 2662 pi.
Yeah.
And then on the smaller one, the only thing we have is the volume.
Yep.
And their question is the height of the larger cylinder and the surface area of the smaller one. Okay.
Mm-hmm.
Let me think for a second here. If we compare the two volumes, that gives us not the cube root of that gives us the relationship between these two heights.
Yeah.
You get that?
Mm-hmm.
Okay. So take this number, divide by this number. Pi's cancel, so you can just do a straight division. What do you?
Okay, it's 3.88.
3.88. Okay, take the cube root of that. Why the cube root? Because volume is in cubic centimeters. Height is just in centimeters. So when I'm comparing the two heights, it's not going to be at a relationship of 3.88. It's going to be at a relationship of the cube root of 3.88.
Okay.
So what's the cube root of 3.88? Take that to the 1/3 power on your calculator.
Okay, hold on. I gotta go grab a different calculator. This calculator doesn't have cube roots.
Well, okay, or I can do it on mine, but
I'll go grab one.
okay, yeah, it's better if you do it actually.
Okay, I grabbed one.
Okay.
So the cube root of 3.88, that is 1.57.
Okay. So 1.57 is going to be the relationship between this h and this 21.
Okay.
So all you have to do is multiply 21 by 1.57.
Okay.
What do you get?
20. You get 32.97.
Okay. Now, notice that the linear relationship is 1.57 to 1, or 32.97 to 21. Okay, that's one dimension. What is the surface area relationship going to be, which is 2 dimensions? It's going to be this squared. Once you find the relationship between single dimensions of two similar volumes, then the surface area relationship is the square of that. And the volume relationship is the cube of that. Well, they gave us the problem in the hardest possible manner by giving us the volume relationship first. So we kind of have to work our way backwards and take the cube root of that to find the linear relationship, which we did. And now the last thing to solve for is the surface area of the smaller one. So square this.
Okay. It is 2.46.
Okay, so the smaller one times 2.46 must equal the bigger one, 1936 pi. And this x is surface area. The surface area of the smaller object times the area relationship, which is 2.46, is equal to the bigger surface area. So what do you get for this smaller surface area? It should be like 700, something like that, pi. In other words, divide 1936 by 2.46.
786.9.
Okay. Now let's examine all three relationships and how we got here. Okay. We have a linear relationship that was 1.57, the bigger one times the smaller one. We square that to find we have a surface area relationship of 2.46 to 1. We cube that, original 1.57, to get the volume relationship. And we find out that when we cube this, we get 3.88, which is how much bigger the volume of the left cylinder is than the volume of the right cylinder. Okay? And this is a very typical problem that you're going to have, but if they were giving you the easy one, they would have given you this relationship first. And then said, well, what's the area relationship and what's the volume relationship? The hardest way to give it is to give the volume first, because then you have to take cube roots of these odd numbers, which, like you said, you needed a different calculator for that. All right. So let's see if I got your second page here. You know, I don't think I did. I don't see another page, another email here. Did you send 2 emails?
Yeah.
Really? I got the first one. I didn't get the second one. Is it something you can verbalize? You might be able to verbalize the rest of these. In other words, I kind of know what we're talking. If we're talking similar cylinders, we can verbalize.
This is just volume.
Okay. What's the first one say? We only have like 13 minutes, so we probably only have time for a couple problems.
It's a sphere with a diameter of 12.
Okay. And what else? There's another sphere?
Oh, no, that's it.
Oh, that's it? And what do they want to know? What its volume?
The volume.
Okay. What's the general formula for volume of a sphere?
4/3 pi r cubed.
What's r here?
6.
So 6 cubed is 216. So you want to give your answer. Does she still want your answers in decimal, or is it better to give it in pi?
Decimal, I think.
Really? Okay. I'm surprised. Usually by the end of geometry, you leave it in pi. Pi is more accurate than whatever decimal you write down. Pi is perfectly accurate, and no matter what decimal you write down, it's going to be rounded off. And let me just say something about that. In the last couple of problems we did, you rounded off at each step. And that is sometimes going to result in a roundoff error. By the time you get to the end, you won't end up with the same answer that your teacher has, because if you don't round off, in other words, if you do it on your calculator and you don't round off until the end, then you're good.
Yeah.
So you want to be careful about rounding off any time prior to getting your final answer. Okay? Okay. So anyway, you can come up with this. What else we got?
It's like this one might be hard to verbalize. It's like actually, I'm going to skip that one. I don't understand how to verbalize that one. The next one's a triangular prism.
Okay. What's the base look like? Is it a triangle?
Oh, it's a square.
Okay. Always have a little
and
like these.
Yeah.
Actually, that's pretty good. No, not really. It sucks. I'm not good at three. I'm terrible at 3 dimensions. Wow. But I think you get the idea. Okay. So what information are they giving us and what are they asking?
The bottom left side is 24 millimeters.
Okay.
The one.
Is there a vertical height, or they give you a lateral measurement?
Lateral.
Okay.
The lateral is 25, and there's another side of 11.
What could be 11?
The bottom, or the base.
Not a square?
It is a square.
Well, how can I have 11 and 24?
Like, it looks like that.
One of them might be a vertical measurement from the top of the pyramid to the center of the square.
No, I don't know. This one's kind of hard to verbalize.
Okay. You see my problem? In other words, if it's a square on the bottom, then all 4 sides have to be either 11 or 24.
Yeah.
I'm guessing that it's like this. In other words, if I drop a vertical to the very center of that thing, that vertical is 24.
Okay.
Okay? And they want the volume of the object?
Yeah.
Well, that wouldn't make sense because it would be too easy then. In other words, the volume of a pyramid, what's the general formula?
Base times height divided by 3.
Be careful when you say base times height. That's not the same base as the base in a rectangle. In other words, if I have a rectangle, that's base times height. This small b is 1 dimension. It's either in feet, millimeters, whatever. This big B, that's the area of the base. So that's in inches squared or feet squared. Okay? So they're not quite the same thing. That's why whenever I say it, I always say the area of the base. And then the fact, if this was a square prism, then it would be the complete area of one base times the third dimension, the thickness between the two similar faces. Because it's a pyramid, it's a lot like a cone. You lose 2/3 of your material. If I was sculpting this from a square cube, I would lose 2/3 of the material, which means the remaining volume is 1/3 of what it would be if it was a prism. And that's true for a cone also. In other words, if I have a cone, the difference between a cone and a cylinder, well, the cylinder is the area of the base times the height. The cone is the area of the base times the height, 1/3 of that. So whenever your middle goes to a point, its volume is 1/3 of what it would be had it been straight up like that. Okay? And that applies to square bases, circular bases, any shape on the base. If it goes to a middle peak, a vertex, then it's 1/3. So if this was the problem I thought you were reading, it wouldn't be much of a problem because the area of the base is 11 squared and the height they gave us was 24. So it's probably not the way I've drawn it. It wouldn't be much of a problem.
Yeah.
Unfortunately, I can't quite figure out what those 3 dimensions could be.
Yeah, it's kind of hard to talk about.
No, that would be the same. Even, oh, no, it wouldn't be the same. Oh, okay. Yes, it would be the same. I don't know. I don't know. I can't figure out what those dimensions are. Let me just see if I got that other email. I did not get it. Huh. Weird. All right. You have one you can verbalize that, like a 5-minute problem?
Yeah, I have it's a cone, and it gives you the volume of 448.
Volume is 448?
Yeah.
448 or 448 pi?
Yeah. 448 pi.
Yeah, the fact that they're giving that to you in pi tells me that they want their answers in pi. They don't want you to use a decimal.
Okay.
That I'm just guessing, because otherwise they would give you that as a number, a decimal to begin with. Okay. Yeah. What else do they give you?
The diameter is 16.
All right.
And we're trying to find the height.
Okay. So the general formula?
Base times height divided by 3.
What's the base?
The base is 16.
That's the problem with calling it the base. Because the base is not 16. It's the area of the base. Capital B means the area of the base. I don't even like the fact that they use the same letter and the same word, because it confuses. In other words, what's the radius of that circle?
Oh, it's 8.
Okay, so what's the area of that base?
Pi r squared, so
64 pi. That's the area of that base. Times the height divided by 3 equals 448 pi.
Yeah.
Now that's fairly easy to solve. The pi's cancel, and multiply both sides by 3 and divide by 64. You have your height.
Yeah.
Okay?
Yep.
What else you got? Got time for one more.
There's just like another sphere with the given volume of 972 pi. And it's asking for the diameter.
Okay. So 972 pi, the volume, is equal to what? What's the formula for the volume of a sphere?
4/3 pi r cubed. So, yeah, pi r cubed.
Okay, so let's solve for r, and then we'll double it. Okay. So the pi's cancel again. Multiply this number by 3/4 to get r cubed. What do you get? You see why I'm multiplying it by 3/4?
Yeah, 729.
729? Did you round that off?
No, that was a clean number.
This would be a case where you would not want to round it off. In other words, let's say you had 5 or 6 numbers after the decimal point. Leave those, and then in your calculator, find the cube root of that answer. You know what I'm saying? That's how you'd be able to avoid round-off error. Well, what's the cube root of 729?
9.
So that's equal to r. What's d?
18.
That's it.
Okay, perfect.
Okay. You good to go, Jackson?
Yep. Yeah.
Okay. If you need another session before your final, I have lots of time on Friday and Saturday, not so much on Sunday. Next week,
Okay.
Monday and Tuesday are fairly busy, so if you feel like you're going to need another session, you might want to schedule it. I've got you down for next Thursday at 3:30. You probably aren't going to.
Oh yeah, can I take that off because school's out by
Yeah,
then?
let's cancel that. Now,
And I'll check my schedule and let you know if I need another session.
okay,
and if I can.
that's fine. You can do that. You can also just go straight on my website, and it'll show you my availability, and you can schedule online.
Okay, cool.
Digitalmathtutor.com is the site you probably should use.
Okay.
All right. Okay, well, Jackson, good luck on your final, and if I talk to you again, fine. If I don't, have a good summer, and maybe we'll work together next year.
Okay, thank you.
You're welcome. Bye-bye.
Bye.